Okay, so welcome back. So now here's the general case. Okay, so and I'm going to do this piece by piece because we're going to take different cases. Okay, so let's say I have this product of cosine and sine to various powers. And in this case, we're going to say that the sine, the power on the sine is odd. Okay, I don't care about the power on the cosine at this point. All I care about is that the power on the sine is odd. Okay? Watch what happens. Watch what I'm going to do here. So in this example here, I've got cosine squared x times sine squared x. Or excuse me, sine cubed x, where this is odd. So what I'm going to do is, this is part of the technique, is I'm going to shave off because, again, I want to do a u substitution. Okay? So, and I want to do u substitution where I make u equal to cosine. And then the derivative of that will be the negative sine, and I can group that up. So I'm going to shave off one of my sines. Okay? So let's do that. So I'm going to rewrite this as the integral of cosine squared x sine squared x sine x dx. And you're probably wondering, well, why would I do that? Because of what you're going to see next. Okay? Because what I can do now is I got this set aside, so this is going to be my du, right? That's where I'm heading. So I need to change this to cosine. Well, there's got to be something I know that I can use, some sort of identity, let's say, that can make this into terms of cosine. And of course there is. And the identity you're going to need to remember is the fact that cosine squared x plus sine squared x equals 1. And so by solving for sine squared x, I can do a substitution here. So this is going to equal cosine squared x times 1 minus cosine squared x sine x dx. And now you see why I did that. Because now I can make u cosine x, du will be negative sine x, and I can do my substitution. So let's do that. So u equals cosine x, du of course equals negative sine x dx. And now I can do my u substitution, and this becomes very straightforward and easy. So this is going to be the integral of u squared times 1 minus u squared du with a negative, right? Because if I multiply both sides by negative, right? And so now this becomes the integral of negative u squared plus u to the fourth du. And now I can just integrate. Now I can just integrate term by term. Okay? So this becomes, this becomes what? Negative 1/3 u cubed plus 1/5 u to the fifth plus c, of course. And so now my final answer becomes, now I'm going to substitute back in for cosine. So this becomes negative 1/3 cosine cubed x plus 1/5 cosine to the 5th power x plus c. And again, if you want to rearrange this so that it's in decreasing powers, then it would be 1/5 cosine to the 5th power x minus 1/3 cosine cubed x plus c. And that would be your final answer. Okay? So now here's one for you. Again, you work it out the exact same way, very similar to what I did. You're going to shave off one of the signs, and then you're going to convert the other signs because it'll be an even power. That's the key, right? If you have an odd power of sine, so think about it. If you have an odd power of sine, what you're going to do is you're going to shave off one of the signs, and you'll end up with an even power of sine left over, and then you can use this. Even if it's sine to the 4th power or sine to the 6th power, you can still do it. Okay? So here's one for you. Okay, so in this example here, notice, oops, hold on. Square. So notice that in this case here, cosine has an odd power. Okay? So all you're going to do is, now this is an odd power, this is even, so we don't want to shave off one of these because then we're going to end up with a sign to the odd power, and we don't know how to deal with that yet. But notice that the cosine here has an odd power. So I can shave off one of the cosines here, match it up with the dx, and then what I'm going to do is I'm going to use a u substitution where I want to use u equal to sine. And then I'm going to still use this identity to make the substitution. Okay, so in this case here, you're going to shave off one of the cosines, and this is going to become cosine squared x times sine squared x cosine x dx. And then what you're going to do is u will equal, did I do the right one? No, u is going to equal sine x right? And you want du to equal what? Cosine x dx. Now, that means I need to change this, or excuse me, I got to change this to sine, because that's what I'm going to use for my u substitution. So here's my dx, or du. Here's my du, right? Here's my du. Now I just got to turn everything into terms of sine. So now this, by using this identity, is going to equal what? 1 minus sine squared x, times sine squared x times cosine dx. And so now I can use my u substitution and then solve. Okay, so I'll leave that up to you to finish. And then if you have any questions, let me know and I'll be more happy to help you. Take care.